Hi. In this video, we're going to refresh and review how to graph equations of lines, and then review how to then solve linear equations by graphing. Okay, so let's take a look at this. This first equation here, we got y equals -2 plus 4x. Remember that that form of the equation is the form y equals b plus mx. And if we write it out that way, we can see that the y-intercept, or the b, is -2, and the slope of the line is 4. Okay. Remember also that if it's just a whole number 4 for the slope, that means it's like 4 over 1. Okay, which means that we're going to have a rise of 4 and a run of 1. So for every x unit, we run to the right, which is the run. For every x unit, or for every 1 unit we run, we're going to be rising 4 units, and that'll be 4 in the y direction. All right, so let's take a look here. Let's go down to the grid. So the y-intercept is -2. So we start at the origin, we go down to -2 on the y-axis. And there's the y-intercept, 0, -2. And then we know that the graph is, or the equation is -2 plus 4x. So the slope is 4. And so from here, we're going to rise 4 units. So from the y-intercept, we're going to go up 1, 2, 3, 4 units, and then we're going to go to the right 1, and that will put another point on the line. Okay, that's finding another point that is on the line that we can use here to then graph the line. And so now I'm going to have to graph this in 2 parts, just the way my software works here. And so I'm going to start here from the y-intercept, and I'm going to go up through that next point that we found, and then I'm going to come down in the opposite direction as well. And that is basically how we're going. Now, it's not perfectly accurate, but that's unfortunately one of the things about graphing by hand. Things aren't super accurate. And so I'm going to see if I can just adjust this slightly to make sure that I do get a little bit more accuracy with this. And so once you get a couple points on the line, you want to extend the line so then we can see if there's any intersections with any other values. So this is the graph of, I'll put this down here, y equals -2 plus 4x. So that's the linear relation. And now that we have that, we're going to now use that to solve 6 equals -2 plus 4x. Well, if I know that y equals -2 plus 4x, and here we've got -2 plus 4x, that's the same thing. That tells me then that y equals 6. Okay, it's both on the left side of the equation. So y equals 6. So I'm going to find where y equals 6, and I'm just going to go up here from the origin. So I'm going to count it where they got 5, and then here's 6 here. So y equals 6 right there. And we have no other values besides y equals 6. But if I were to come along here, this is also y equals 6 right here. This is another point, that's y equals 6 right here. Here's another point, that's y equals 6. Also back over here, that's a value of y over 6. That's also y equals 6. So any value that's just y equals, that could be any point that has the y value of 6. They all have different x values, x coordinates for those points, but they have the value of y equals 6. And so now I'm just going to then draw a horizontal line through that. And that's the horizontal line through y equals 6. And I can just state that as y equals 6 here. And then therefore, now, had this first graph been a little bit more accurate, we probably would have seen that they would have intersected right there. And actually, maybe I'll just adjust this slightly again. there. Okay, so it does go through that point of 5, 1, or sorry, that's not 5, 1, that's 2, 6. Goes to that point 2, 6. So counting up the slope like I did before, I went up 1, 2, 3, 4, and then to the right 1. And then if I go up, I rise another 1, 2, 3, 4, and then run 1. I see I get to that point 2, 6. And so that means that when y equals 6 and the equation y equals negative 2 plus 4x, we see that the value, the x value that makes this true is the x value of 2. So when you have the equation 6 equals negative 2 plus 4x, by graphing, we see that x equals 2, and that will make that make this equation true. Okay, so that is how an example of how to solve a linear equation by graphing. All right, let's move on to another example. This time we're going to graph y equals negative 3 minus 3 halves x. So same thing again, we've got y equals b plus mx as the standard form here. And we see that the b, the y-intercept, is negative 3, and the slope, m, is negative 3 over 2. So we're going to start off by plotting the point of the y-intercept. So we start at the origin, and we're going to go down 1, 2, 3. So that's where negative 3 is, or the coordinates are 0, negative 3. And then from there, we remember that the slope is negative 3 over 2. And so that means that the rise is up top here, and the run is the bottom of that ratio. And so by convention, we always keep the, we always run to the right. So that means I'm going to bring the negative up into the numerator and then make this a positive. So it's going to be negative 3 plus negative 3 over 2x, and which means that I'm going to rise down 3 as I run to the right 2. Okay, so from this point, from the y-intercept, I'm going to go down 1, 2, 3, then I'm going to run 1, 2 to the right. There's the next point that is on the line, and then I'm going to now draw the line as accurately as I can. And I'm going to draw another line in the opposite direction just to kind of show that I'm extending the line in both directions. So there's the line, y equals negative 3 minus 3 over 2x. And I want to, now that I've done that, I want to solve this equation. Negative 3 minus 3 over 2x equals 3. So even though this is turned around from the last example, this is the same as y equals negative 3 minus 3 over 2x. And notice that the y is 3. And so basically 3 equals negative 3 minus 3 halves x. And so I just have to plot where the y value of 3 is, and the y value of 3 is right here at 0, 3. And then here is a point 2, 3, 5, 3, 7, 3, etc. Here's negative 4, 3, negative 8, 3, etc. And so I'm going to now draw that horizontal line that goes through y equals 3. And now I realize I have to extend this line a little bit further to make sure that I have an accurate intersection point. And so now I just see that the intersection point is right here, and the coordinates of that point are negative 4 and 3. So when we have negative 4 and positive 3. So negative 3 minus 3 over 2x equals 3. By graphing, we see that that the x value that makes this true is x equals negative 4. Okay, thanks for watching, and we'll see you in the next video.